everybody! Today we're going to be talking about adding and subtracting integers, which goes with the learning goal I can add, subtract, multiply, and divide integers. And obviously we're just taking the first half of that today. Just to remind you, integers are whole numbers and the opposites of whole numbers. So numbers that don't have any fraction or decimal part, like positive 10 or negative 3 or something like that. And we want to talk about what we do when we add and subtract those. For my first example, I'm going to talk about adding. What happens when I add a positive number to a negative number? So I want you to think about this group of circles over here as a negative number. They form a negative number. And then this group of positive signs over here, that forms a positive number. So if I count these up, I have 8. So I'm going to call this negative 8. And then over here I have 4, so I'm going to call this positive 4, and with positives we usually don't write the positive sign, so that would just be a 4. And I'm going to say, well, what happens if I add these two together? When I add a positive and a negative number together, it's like a battle. Positives and negatives are like numbers that they're two groups that are feuding with each other. And so they can't get along. If there are positives and negatives, they will automatically fight each other to the death, and then whichever group had more, those will be the only guys left standing. So what we're going to do is we're going to pair these guys up. So one positive goes to one negative, and they do away with each other. Then we have another positive and another negative, and again, they can't stand each other. They get rid of each other. Then we're going to have this positive, they're both going to pair up with a negative, and again, get rid of each other. And so you can see, because there were more negatives, those are the guys left standing, and there are 4 of them left. So when I add negative 8 plus 4, I'm going to end up with negative 4. These guys are all gone, the ones that paired up. 1 negative plus 1 positive equals 0. If you don't like the violence of the metaphor, but basically they get rid of each other, they cancel each other out, and you're left with just whatever's left over, the negatives in this case. So here's another example of what could happen if we have a negative number and a positive number that we're adding together. So this is again addition. And so if I look at the negative signs over on the left hand side, I can see there are 5 of them. So this is like negative 5. And I'm adding that to the number of positives on the right. So I'm adding that to positive 9. Again, my guys are going to pair up and cancel each other out. 1 positive with 1 negative each. Or if you prefer the fighting method, then these guys are going to do away with each other. They've now had their fight to the death, and there are 4 positives left standing. And so we know that negative 5 plus 9 equals 4, positive 4. You can see that when you add a positive to a negative, they're just going to cancel each other out. And if you look at the numbers there, it's like we subtracted. 9 minus 5 equals 4. When we do that subtraction, we're ignoring the signs on the numbers. I'm just doing 9 minus 5. And so if you remember back from the last lesson, that's like taking the absolute value, because remember the absolute value is always just looking at the positive number without the sign. It doesn't matter which sign it is. It's a number's distance away from 0. So negative 5 is 5 units away from 0, 9 is 9 units away from 0, and then I just subtract those two if the signs are different. And we did the same thing up here. If I look back here, if I had taken the absolute value of 8, or of negative 8, that's 8. Absolute value of 4 is 4. 8 minus 4, I get 4, but now my answer is negative because there were more negatives, basically, because negative 8 has a larger absolute value, so it's going to pull the answer over onto the negative side. Whereas on this one, 9 has the larger absolute value, so it pulls the answer over onto the positive side. There's more of those guys left standing. So what happens when I add 2 numbers together that have the same sign? For example, if I add 2 negative numbers together, on the left-hand side, I have 5 negatives. So I am adding negative 5 plus, on the right-hand side, I have 6 negatives. So I'm adding -5 plus -6. Well, if negatives get together, because they're adding, we're putting them together, they don't dislike each other. They're not going to kill each other off. They're just going to have a big old party. So we're just going to move these negatives over here. Everybody's hanging out. Everybody's having a good time. And I can just count those up. I can see that there are 11 of those, and they're all negative, so we're going to stay with -11. So when I add two numbers together that have the same sign, I just add their absolute values. So I'm adding 5 and 6, and I'm keeping the sign the same. And that's going to work the same if you add two positive numbers, which you've been doing since, pretty early in grade school, so I'm figuring you can do that. Now when we think about subtraction, this is a little bit more complicated. I'd like you to think about if I had all of these, if I had some positive and negatives together. So they came together, they haven't had a chance to quite cancel each other out yet. But if I look at the value of this, what it's going to be once those positives and negatives cancel each other out, I can see, well, these guys are going to cancel each other out. Maybe this guy and this guy, 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 and I can see there will be, that the value of this is going to be +4. Pretend that this is a representation of +4. If I go ahead and I subtract a positive number away from that, so let's say I take away 6 positives. So I'm subtracting 6 positives. That would be like these guys are getting sucked into a vortex or something. They go into a different world, they disappear, or they just go home, however you want to think of it. But so I'm going to take 6 of these positives and have them disappear. I've taken away 6 of my positives. So now when these guys go off and have their fight, the negatives are actually going to win. So these guys get rid of each other, and I'm left with -2. So I had something that had a positive value, and I subtracted away some of the positive, more than the number was worth, and so I ended up in the negative direction. So that's subtracting away a positive. What happens if I subtract away a negative? Let's look at the same situation. So remember that this number right here was worth a +4. Okay? Now, let's say we subtract away some of the negative. This is right before the beginning of the battle. Right before the beginning of the battle, oh no, some of the negative guys, moms call, they have to go home. So we're going to take away 3 negative guys. They got called home by their moms. So how is that going to affect the outcome of our battle? So these 3 guys right here disappear, and now there's only 2 negative guys left. And you can see these guys are going to cancel each other out. These guys are going to get rid of each other. And so then I'm going to still be left with 7 positive. My number actually became more positive because I got rid of some of the negatives. So my positive guys actually won the battle even better than they would have before because we got rid of some of the negatives. So that subtraction problem, when you subtract out a negative, your number actually becomes more positive. Now, let's say you don't want to draw these little tokens every time to figure out the answer to your problem. What we a lot of times do when we're subtracting positive and negative integers is we just change the subtraction problem to an addition problem. Remember that subtraction and addition are sort of opposites of each other, and I can actually change back and forth between subtraction and addition. If I want to do that, let's say I had my 4 minus -3, and I just want to change that to an addition problem because that'll be easier for me to solve. I'm going to always leave the first number the same. So this first number is never going to change when I change a subtraction problem to an addition problem. It's always going to stay the same. And then I'm going to change this to an addition, but you can't just change a subtraction problem to an addition problem and expect the answer to stay the same. When I change a subtraction to an addition, I have to add the opposite of the second number. We know how to find the opposite. It's a number that's the same distance away from 0, but on the other side of 0. The opposite of -3 is +3. So if I add 4 plus 3, I'm going to get 7. And that's just the answer that we found when we looked at the tokens. And if we look back at the other problem, we had 4 minus 6. If I want to change that to an addition problem, I'm going to leave this first number alone. It does not change. It gets to stay the same. Now, I'm going to change this to an addition, but I can't just change it to an addition problem. I can't expect to get the same answer if I do that. So I'm going to add the opposite of 6. Well, the opposite of 6 is negative 6. So now I'm adding 4 plus negative 6, and I get negative 2, because the positive 4 and 4 of the negatives are going to cancel out, and I'm left with 2 negatives. And that's the answer that we got when we did it with the tokens too. So changing a subtraction problem to an addition problem has 2 steps. I'm going to leave the first number alone, and then I'm going to add the opposite of the second number, and that will change it to an addition problem.